Thank you and welcome to today's episode in the Caserta Data Intelligence webinar series. My name is Remy Rosenbaum and I'm the VP Marketing at Caserta. I'll be moderating today's webinar. In this episode, we're going to explore the top business intelligence trends of 2019. At Caserta, we're helping leaders like you who are looking to innovate by and through their data, gain competitive advantage for their companies, and to reduce their time to market. We provide strategic consulting, design, and advanced implementation across the full data ecosystem. Our analytics services are design-led and framework-based, which greatly reduce time to delivery, as well as improve the accuracy and impact of the outcomes. Our uncompromising dedication to finding the right answer to our clients' tough data challenges while ensuring the fastest time to value is a hallmark of our firm. Caserta's complimentary industry expert webinar series is designed to give you insight into today's hottest technological trends and issues. After the webinar, you are encouraged to contact us with any questions on how to apply what you have learned today at your firm. Following the completion of the webinar, a recording of today's presentation will be sent out to the email address you provided. If you have any questions throughout the presentation, please enter them at the questions panel on the right, and we'll answer them during the Q&A session at the end of the webinar. In today's webinar, we're going to hear from two great presenters who will explore the trends that are shaping business intelligence in 2019. First, we have Srividya Bobji, a leading BI consultant with nearly 2 decades of delivering analytics-driven solutions. Srividya was the lead BI architect at AIG and has consulted on BI projects for diverse companies, including the New York Times and WWE. Then we're going to hear from Daniel Mintz, the Chief Data Evangelist at Looker. Previously, Daniel was head of data and analytics at fast-growing media startup Upworthy. And before that, Daniel was director of analytics at political powerhouse MoveOn.org. Throughout his career, Daniel has focused on how people interact with data in their everyday lives and how they can use it to get better at what they do. So let's begin with Srividya. I'm going to pass this over to you.
Can everybody see my screen? Okay, so hello everyone, and very good afternoon. This is Srividya Bobji, and we'll take a look at what is in the business intelligence trends for 2019. And before we jump on the trends for 2019, let's take a look at the paradigm shift in the last decade and how that kind of shaped into moving forward in the way we consume the BI and analytics. So the key shifts in the BI analytics world is a couple of the ones that listed here, starting with being more of a centralized function to moving to a distributed world, as information is power, and there's more need for the data democracy and collaboration. And for better collaboration, equality, and innovation, that kind of led to more of a distributed data ownership. And the second key shift we saw is from being an IT produced to more of an IT enabled, empowering the business with more self-service and data discovery mode with non-technical skills, and enabling them with more autonomous execution of the BI workflow, right from data access to ingestion to preparation to interactive analysis and collaborative sharing of insights. The next key shift we saw is from being more retrospective in nature to being more predictive in nature. So from just reporting the facts of the past occurrences and finding patterns and relationships among many factors, and identifying risks and opportunities from the current and historical data, using various statistical methods and advanced machine learning models to predict the future of the unknown events. And the last key shift that we saw was from moving the data from on-premise and legacy systems to more of cloud migration. So with the advent of the big data and IoT, more and more organizations turning to cloud storage from on-premise compelled to use the modern data platforms to address the big data needs and challenges. So we see more of a hybrid approaches, as well as the advent of edge analytics. So what edge analytics means is the analytics is performed much closer to where the data is actually created, like the sensors or the wearable machines, smartphones, healthcare devices, etc. So these are much more richer analytics, and the demand to kind of force us into more cloud migration and to do more of distributed and edge analytics. So with these shifts primarily forms the premise of how we consume BI going forward. And the top trends that I will focus on today's webinar will be on the consumption of BI, and not necessarily covering anything related to technical or infrastructure or the implementation aspect of it. So we have five trends that I would cover today. One is the augmented analytics, the embedded analytics, conversational analytics, data monetization, and data collaboratives. So let's look at each of this and how it kind of impacts the way we kind of consume data. So augmented analytics. So Gartner defines this as an approach that automates the insights using machine learning, AI and machine learning, and NLG in order to improve the overall speed and accuracy of providing insights. And this kind of enables a quick and timely decision making. For example, some of the complex ML models producing opportunity analysis, churn analysis, attribution studies, etc., can be readily made available for the field users, so that they can take timely decisions. So that's the augmented analytics. And the second one is the embedded analytics. So as the name suggests, embedded analytics is the kind of use of reporting and analytics embedded within the transactional business applications. We've had transaction systems in BI which siloed, and the users were kind of forced to switch between the systems, and BI was always at the end of the business process life cycle. But we needed more of a continuous analytics, and have the BI or analytics is more pervasive in the process, so that it compresses the analytics life cycle and gives more maximum value for the data by providing real-time decision making on the perishable insights and offers more contextualized insights. The third trend, which we will see more, is the conversational analytics. And the narrative science has been evolving, and this is kind of a key part of our day-to-day lives here, where the conversational analytics is nothing but speech, and we convert it to data, and we find insights within that. And it is more of a NLG, NLP, and NLQ are the like the science, the narrative science behind that offers the augmented data discovery. And AI-based analytical assistance we do use in our day-to-day life, with our mobile devices, like the Siri, Alexa, Google Home, and several other chatbots, to kind of ask questions and interpret the data. And this is much more richer and actionable than any of the traditional analytics, because it's more contextual, and it's more actionable. The fourth one is the data monetization. This has been around, but so the way Gartner coins a new term called infonomics. So this is creating a revenue stream for your organization's data assets, and data can be made as more of a income generating assets, and we already have this via our GPS enabled smartphones, geolocation based data that we can do a targeted marketing campaign. And all of these sensor-rich consumer electronics, like mobile phones, wearable devices, etc. So all these rich data can be monetized, and this we would be seeing more and more of it. And the next one is the data collaboratives. So data collaboratives is a new form of collaboration. So where the different organizations share or exchange their data in order to create more of a public value, in order to address and help the societal needs. And this is more used in the medical research field, especially in cancer research, public health, climate change, and other research studies. And this one does not have a direct income for the or it does not generate a direct revenue or income for the companies. But then any such valuable data that has been shared for the collaborative purposes, these organizations can get more of a tax incentive for sharing the data. So that's all I had. So the top trends being the augmented analytics, conversational, embedded analytics, data monetization, and data collaboratives. So thank you. So I will hand it over back to Remy for the next presenter.
Thanks, Srividya. And again, you're encouraged to ask Srividya any questions you have in the questions panel on your right. Now we're going to proceed with Daniel, and I'm going to pass it right over to you. Daniel, here we go.
Thanks, Remy. So I'm going to talk about some broader data trends that I see coming in 2019. For those who don't know, Looker is a data platform, a BI tool, sits on top of your data in the database and makes it accessible to everybody in the organization, but ensures that the answers that they get are consistent. And some of these trends that I'm seeing, I think, do relate to sort of what Looker's doing in the market, and some don't. So I'll touch on that. So the four big trends that I want to talk about, one is just new jobs in data. Another is sort of big metadata, not big data, but big metadata. A third is democratizing the sort of predictions and predictive analytics. And the last is around the infrastructure that we use to run AI and machine learning. So on the new jobs, I think the way I've been thinking a lot about this lately, and I think that there are some really important data jobs that you may have never heard of or never met anybody who has any of these data jobs, but I think they are going to become really widespread pretty soon, because as the data industry grows, I think these things are desperately needed. And one way to think about them is to look to other industries and see how they've developed and what jobs have sort of shown up later. And so one is really around product management, the product manager. I think in the beginning of certainly of sort of agile software development, product management was not a real discipline the way that it is now. But people realized that there was this really important role at the nexus of sort of user-centric design, the technology, and the business need. And we call those people product managers, and they are really critical to the success of a software project. And I think what we're going to see is that we need the same thing in data. There is a growing demand for data across the enterprise. So the people and types of people who are working with data in their daily jobs is growing tremendously. And those people are not necessarily trained on BI. They're not necessarily comfortable, logging into a BI tool. And so if they're going to get value from data, we need to be conscious of how they're actually interacting with the data tools that they're using. We need to build tools that are intuitive and make sense to them. And if we're going to do that, we need to not just sort of present the data in the way that we're used to and hope that they can figure it out, but rather, think about what lives at the nexus of these three things. So how do we design sort of user-centric data products? How do we make sure that the data, is well curated and accessible and accurate? And then how do we make sure that what we're building has real business value? So I'm super excited about the advent of more data product managers. I think it's a critical role that is overdue. Another one of these really important data jobs that you may never have heard of is the data ambassador. That elides nicely, the data ambassador. So the data ambassador is somebody who usually lives on the business side. They're not an analyst themselves, but they're the person in their department or their group who's really excited about data. They see what data can do for them in their job and want to take that message to their colleagues. And so, I think if we're going to see the kind of adoption of data tools that we really want, the only way that that's going to happen is if we have advocates on the business side who see the value and are telling their colleagues about it, who are driving that sort of viral adoption inside their departments. And so, I think finding data ambassadors in your company who are not on the data team but are excited about data and can talk to their colleagues, bring that message to them, is a really powerful tool for spreading adoption. A third data job, and I think this one is one that I see the best analysts I know already doing, is data translator. I'm not really sure why the Canadian and United States people in the picture need translators between them, but maybe they're French Canadian. But I think this role of translating between the business and the data is really critical. There's just no way that the data people, the people who really understand how the data is structured, where it lives, how to move it, how to optimize it, those people can't be subject matter experts in everything the business needs from data. And simultaneously, the people who are subject matter experts, who really do understand what the data is supposed to mean to the business, are not usually experts in all of the technical data things. What kind of data warehouse should we build? What kind of schema should we build? And so the people who can sit between those two poles and do that translation work are immensely valuable in data project success, because if you don't have somebody playing this role, what often happens is either you build something as the data team that you're really excited about and it's very technically challenging, and you turn out something and it's very performant and you're very excited about it, and you put it in front of business users and they look at it and they go, I don't know what to do with that. And that's a terrible moment. But the problem is that you didn't have a data translator on your team who was, actively communicating the business people's needs, or maybe lacked a data product manager. The other thing that often happens if you don't have a data translator is the opposite direction, where the business team comes and asks for a thing. They say, I need a dashboard that shows sales by region, by month. And because they don't actually know how the data is structured and all the details that go into data work that we all know about, they are asking for the thing that they think that they want, but isn't actually what they want. And so you go and build exactly what they asked for, but you lose all the nuance. And so when you put it in front of them, they realize, oh, this is not actually what we needed, which is pretty frustrating as a data person, because now you have to go back and rebuild it or not. But if you had that data translator, they would have been the one to say to the business person, well, you're saying that you need sales by region by month, but did you know that our definition of region changed last year? And so that might be misleading. And business person says, no, I had no idea. Well, I have this other piece of data. If we do it by country, those haven't changed. So, maybe let's do it that way. And then we can turn it into regions later, and that'll account for that discrepancy. Oh, wow. I had no idea about that. And so that data translator's job of sort of translating the requirements from one side to the other, and the opportunities and the capabilities, is really critical to the success of data projects. So, that's one big trend that I'm seeing, is just that there are these data jobs, these roles that are surfacing that maybe we didn't think about a lot, but actually are really critical to the success of data projects. Another big trend that I'm seeing is just, there's an enormous amount of data being created every day. There's some stat about the number of zettabytes of data being created. I have no idea what a zettabyte is, but it sounds like a really big amount of data, and I think it is. And people tend to think, oh, well, it's IoT data, it's log data, it's machine generated data. So it won't be dirty. It won't need anything to be able to put that to use. We'll be able to put it right to use because it's just machine generated data. And I think what they're missing is that with big data, we need big metadata. We still need all of those pieces that tell us what the data means. The metadata about the data, because data is not very useful. What we want is information and knowledge and insight. And the only way to translate raw data into those things is with metadata that tells you what's supposed to be there. I think as analysts, as data people, a lot of what we do is about defining what is supposed to be there, what we expect to be there, and then comparing that to the reality that the data shows us. And the only way that we can know what was supposed to be there is with that metadata, because that takes knowledge about the subject, takes knowledge about, oh, well, this is an IoT, data stream, and it's supposed to send data every 60 seconds, but it's not. Okay, that's a discrepancy. We want to dig further into that. But if you don't know, where the data is coming from, or that it's supposed to ping every 60 seconds, or what that data is supposed to look like, you're not going to be able to make sense of the data. And no amount of artificial intelligence or machine learning is going to solve that problem for you. So I think as we collect larger and larger volumes of data, we need to remember that big metadata needs to come along for the ride if we're going to get real business value from it. So a third trend that I'm seeing is that, it used to be that artificial intelligence, machine learning, whatever you want to call it, was sort of the domain either of academics, nerds, data scientists, who were really excited about it because it's pretty cool stuff and pretty amazing. But, they would often focus on things that were interesting, but not necessarily useful from a business perspective. So, I think those folks have long been into AI and ML. Or when you did see it in the business world, it was kind of on the bleeding edge. And the companies that were using it were really either huge tech companies that just had the ability to hire amazing experts who could bring this knowledge into their companies and make it work for them, or they were small startups that were just focused on an AI or an ML problem, and so they were able to grapple with all the complexity and the difficulty of these systems and these algorithms. And so those were the two places that you saw AI and ML at first, was really either in these more academic settings or in these bleeding edge companies. And I think in 2019 and going forward, we're going to see this predictive analytics really start to be democratized further out into all kinds of companies. And there are a lot of reasons for this. I think people are getting smarter about what AI ML is good at and what it's not so good at. The tools that you need in your tool belt in order to do this type of predictive analytics is getting smaller, because more and more of the specialized pieces can be taken care of for you by others. I think it's getting built into more and more tools that are being used across the business for predicting marketing spend or forecasting sales revenue, things like that. And so that gives people a taste of what's possible, and I think that will continue, and they'll start wanting this in more and more places. And I just think that this democratization of predictive analytics is really great. I think it will sort of puncture some of the hype, which is great as well. People will realize that AI ML is not going to solve every problem magically tomorrow, but that it is an incredibly powerful tool to have in your tool set for certain kinds of problems. And I think the types of problems that people focus on will certainly increase as the research continues, but I'm really excited to see this democratization happen. And then the last trend that I just want to talk about is about machine learning, but really about the machine learning infrastructure. And I think anybody who's done some data science, who's dabbled like myself, knows that spinning up something on your laptop is not particularly hard, right? You want to do a little bit of analysis, using SciPy or MATLAB or R, not that hard, because the quantities of data that you're looking at are, pretty manageable. But doing that at scale, if you're somebody like Netflix, running recommendation algorithms for many millions of customers across every geography in the world, pulling in billions of data points, that's really hard to build tools that can scale up, and you end up with architectures that look a lot more complicated even than this. A friend of mine used to be the director of algorithms at Netflix, and their testing infrastructure was enormous, and that was small for them. Running production machine learning to make the recommendations work on your Netflix queue was just, it took an enormous amount of energy, not to sort of perfect the algorithms, but just to make them scale. And so, the idea that people would solve those problems, those scale problems for you, was was a pipe dream at that point. But technology being what it is, a few years later, sure enough, people are solving those problems for you. And so what we're starting to see is these machine learning as a service products. Things like Amazon SageMaker and BigQuery ML. I'm going to talk a little bit more about each of them, but these fascinating, amazing projects where they are really taking a lot of the complexity out of scaling up the sort of test machine learning algorithm that you built locally to something that can scale to enormous quantities of data and be running in production. So, Looker is tightly coupled with both of these partners and both of these tools, and we think what they're doing is amazing. We love working with folks who are pushing the envelope on machine learning because, if you think about a machine learning workflow, it's really 3 steps. Step 1 is, clean up the data, getting it ready, labeling it, pulling the features that you care about out of that data set. The second step is actually building the machine learning algorithm and tuning it. And the third is then operationalizing whatever you found and putting it back in the hands of decision makers so they can use that information. And Looker is really good at the first and third steps there. We are not particularly focused on that middle step of actually building machine learning algorithms, but that's fine. That's why we have great partners who do exactly that. And so watching them innovate and make the whole pipeline more powerful is wonderful. So just to give folks a little bit of context about each of these. So Amazon SageMaker is machine learning as a service. They offer a whole wide variety of different types of machine learning. They offer all of the pieces, like they'll even, you can give them some of your training data and they will have humans do the initial tagging of that data. So if you want to, find all the windmills and pictures, they'll have people go through and tag all the pictures with windmills and then use that to train the next set and the next set. And then when you're ready to scale that up to production, they have, enormous resources, being Amazon, to scale that up on, specialized machines that can scale this very quickly to petabyte scale data sets. So, you just put your data sort of on S3, whatever that data is, point SageMaker at it, and SageMaker takes care of the rest and puts the results of its predictions right back on S3 for you to use and operationalize. It's pretty amazing stuff. BigQuery ML from Google is an even tighter integration. So right now, at last check, they only offered a couple of machine learning algorithms, though I think they're adding more. But they're actually not even putting the data in something like S3. They're using BigQuery, which is Google's data warehouse, to actually do the machine learning, to do the regressions directly in there. And so, as you can see, you actually can call the machine learning prediction algorithm right there from something that looks just like SQL, that is effectively SQL. And so if you're a Looker user, you can actually build machine learning models directly in Looker. You can push the results of those predictions out into a BigQuery table and explore those results to assess how accurate they are, all within Looker without ever leaving the Looker platform. So in both of these cases, Amazon and Google obviously have really extraordinary engineers and infrastructure engineers and algorithm training engineers, and so you're leveraging all of that expertise and allowing them to handle all of the complexity, the DevOps, workflows of scaling these machine learning, tasks up to enormous data sizes without having to worry about all of that. So, as easy as it is to do locally, it's just about as easy to do in the cloud on massive data sets. So those are kind of the 4 big trends that I'm excited about. These new jobs, the machine learning as a service that I just talked about, the democratization of prediction, and big metadata on big data. And with that, I will hand it back to Remy.
And so you should see in the right-hand panel a space to ask your questions. So the first one, will NLG serve as a data translator someday? Daniel, I guess that one's for you.
I mean, yeah, I'm happy to jump in. So I think yeah, I guess actually I was going to say I think you mean NLP, but I guess really you could mean both. So for anybody who's not familiar, NLP is natural language processing, NLQ is natural language querying, and NLG is natural language generation. So they're kind of both ends of the spectrum of I ask Alexa or whoever to answer my question would be NLP or NLQ. And then, Alexa takes or Google or Siri or whoever takes a data set, a result set that, might have been visualized as a chart and tells me about it and says, so sales were up this year, but there was a dip in October. So that would be NLG. I think there's no doubt that they can be effective tools to help that translation process. I don't think they're a substitute. I think the work of actually understanding what the business's problem is the real critical part. And the reality is that business people aren't always good at stating what the business problem that they're trying to solve is as a data problem, right? That's really what great analysts are good at, is being that interface where the business person comes and says, I need this data, and you say, well, I'm not going to just give you that data set. Tell me what you're actually trying to do. And the business person hopefully says, well, what I'm trying to understand is this thing about the business. And the data person says, well, then the better way to ask that question, the data would be this. So, I don't see that happening anytime soon with Siri. But, I do think it can certainly be an effective tool in the arsenal for making it easier for business people to ask questions and then giving them another way to understand the results.
Okay, thanks. We have another one on, there's still a challenge on analysis on unstructured data. From your perspective, how are organizations today tackling that?
Yes, unstructured data is hard. I mean, I think sometimes when people talk about unstructured data, what they really mean is semi-structured data, something like JSON. And that's, I would say that the ability to process JSON data and make it useful, or semi-structured data, is grown tremendously over the last few years. Many of the most powerful data warehouses today have really powerful JSON parsing, or tools for parsing other semi-structured data, XML, things like that. And so the ability to sort of impose some structure on that semi-structured data is really growing. On truly unstructured data, on here is a blob of text, or here is a video file, that's a very different problem. And I think that's a place where trained data analysts are really are sort of essential, because they're the ones who can understand, what are you trying to understand from this big blob of text? Is it just you want to know how many times this word appears, or is it are you trying to break a cryptographic algorithm? Like, what are you trying to do with it? And they can then pull from their much larger box of tools and use the right tool to do that.
Okay, thank you. The next one we have is on prescriptive analytics. Do you see prescriptive analytics for business intelligence platforms reducing the need for data scientists within some standardized industries?
I mean, I have yet, I'd say no. I'm gonna come out. I'm not gonna equivocate. I'm just gonna say no. And here's why I say that. I say that because we sometimes get that question from people who have been doing business intelligence for 20 or 30 years, and they're like, well, if you if you have a system like Looker, aren't I going to be out of a job? And the reality is that no, they never are. There's always more work to do, and it just means that you don't have to worry about this sort of boring, repetitive, low-level tasks that you probably didn't enjoy that much anyway. You can focus on the higher order tasks that only you can do. Yeah, I mean, I think will prescriptive analytics solve some specific problems? Absolutely. I think that will be really great, but there's never, I don't see any future where we run out of interesting or useful things for the analyst to be exploring. So I think it will just free up the data scientist time to not work on that sort of solved problem, but go tackle a new one.
Okay, and we have one last question. I'm going to preface the question by saying, obviously, the first thing to do is to talk to Caserta. But the question that came in is, what is some advice on starting a BI project and choosing a BI tool? So I guess you're partial to Looker, but go for it.
Have Caserta tell you to use Looker, and you're done. No, I mean, I think if you're starting a BI project, I mean, that's a pretty broad question, but I would say, you always need to ground these initiatives in what the value to the business is, because that's how you justify them, right? That's how they justify their costs. So, I always recommend, if you're picking your first sort of area of inquiry or, data source that you're pulling in or project that you're tackling, pick one that will have a very clear and direct impact on the bottom line. Because if you do that and it works, then you're a lot likelier to get more funding for the next project. I think start there. Start with understanding if this really works the way we hope it does, what will we know about the business that we don't know now, and how will that drive revenue, or how will that lower costs? Once you've done that, I think, the reality is I do think that sort of engaging somebody like Caserta, if you don't have that expertise internally, engaging a consultant is a great way to get a feel for the landscape. The list of data tools that are out there just keeps growing, and capabilities just keep changing. And so, nobody can keep on top of all of it, but engaging somebody who is in touch with all of these different vendors and has, opinions about what's working well, is a really valuable thing. I'd also recommend we realize that we have an enormous amount of information and knowledge internal to Looker about all of the different databases and data warehouses that are on the market. And we thought that was silly to keep all of that knowledge inside Looker. So we built a little microsite that talks about all the different kinds of databases and different specific databases and their strengths and where they excel. You can check that out. It's databases.looker.com. It's a great resource. But I think, I would say start with business value, find somebody who really does understand the landscape and how things are changing, and go from there.
All right, excellent. Daniel, thank you so much. Srividya, thank you so much. Everyone else, if you have any further questions, please don't hesitate to email me, remy@caserta.com. And after we get done processing the webinar, I'll send you all links so that you can see it on demand. Again, thank you so much, Daniel and Srividya. It was a great webinar. Thanks, guys.